Okay, so hello. My name is Tomáš Mariančík, and I usually go by nickname Fruxius. I have been working on virtual reality applications since the Oculus DK1, and today I would like to share with you my design principle that I use for creating almost all my VR applications, and that's essentially that VR allows you to break the laws of physics. So let me just start the presentation. There we go. So I'm the co-founder of a company called Solirax, and we were funded by the Rottenberg Ventures as part of the first River VR accelerator. So first, about a few of my projects that you might have known, I have created experiences like SightLine the Chair, Neos the Universe, Neos Origin, World of Comenius, VR MRI visualizations, and currently I'm working on big Neos VR, which is a word engine for virtual reality. So why do we need the design principle? Well, the thing about VR is that it's a very different medium from a computer screen. So a lot of the design practices that you are familiar with don't transfer well, and even if they do, they don't really utilize the potential of the new technology. And it doesn't matter if you are designing games, educational or social experiences. So because of that, we need a new way of thinking about this medium when we are doing our design decisions. And that is like when deciding how the software is going to work like, what's it going to be about, what are going to be its core principles, and even how is the user going to interact with the software. And for this, I have came up with the idea that VR essentially allows you to break the laws of physics, and it allows you to get rid of the limitations of the real world. So I'd like to show you how that came to be and how it influenced a lot of my projects and how I based my design decisions on that. So the first of my prominent projects was a game or an experience called SightLine, and later SightLine the Chair. And it actually started as the basic idea: what would the world look like if the laws of physics were somehow broken? And when I started thinking about it when I was still waiting for my DK1 kits to arrive, and I was essentially thinking that we already live in the real world. So if we had VR experiences that just copy it, maybe with little tweaks here and there, they would seem mundane and boring in a way, because we don't need a VR headset to experience those things. We can experience them in real life. And I thought that the real power of VR was being able to create experiences and worlds that couldn't exist otherwise. And in psychology, one of the first things our brains learn about the world that we live in is the object permanence. So I thought it would be interesting to break that principle. So in SightLine, the entire world is volatile. If you look at a chair and glance away even for a moment, it might turn into a door. Or the entire scenery can change around you if you just look around. This created a very unusual and surreal experience and opened a new way of storytelling and even transitioning between sceneries, because which also had a added benefit that it didn't make people sick, because there was no actual movement. You just look around. But the interesting thing about this was that this mechanic, it didn't have nearly the same impact when it was displayed on a computer screen. And when we are in VR, you feel that the objects or the environment are actually there. So when they unexpectedly change, it actually feels like the world around you is doing something that it shouldn't. Something that you wouldn't normally experience, and something that your brain wasn't equipped to handle, which made the experience so surreal and so interesting and compelling. But I also feel that it would be boring and unimpressive when it was just on a computer screen. It was essentially a principle that needed VR to work. And that's when I first learned, don't be afraid to break the laws of physics in VR. When you are creating visual worlds, you are not constrained by the way your world behaves and works. And your constraints are essentially only the computing power and your own imagination. What this means is that VR allows you and us to have other people step into our own imaginations and the worlds that we imagine, no matter how bizarre or unusual they are. And it essentially allows us to enter into worlds and universes that wouldn't exist in the real world. And that's what I think that makes them so compelling. After SightLine, I have started working or exploring how VR could be used for education. And I eventually developed a project called World of Comenius. It was essentially a concept demo exploring how education in VR would look like. But I didn't want to just create a classroom that happens to be in VR, but instead to create a virtual universe that could be freely explored and interacted with. So instead of listening to a lecture, you'd learn about the subject by directly experiencing it, or by experiencing the historical context that where the knowledge or the subject essentially arose. So you'd be actually a part of the discovery process itself. Like if we met with Newton or Einstein, and you were their lab assistant, and you actually perform the discovery yourself, or sort of rediscovery. And the reason for that is that many scientists have a way of visualizing and thinking about the subject in their heads. They have a way of intuitively grasping the topic, or there's a nice sci-fi word for it, like they grok the subject. For example, there's a famous story about how Albert Einstein essentially imagined chasing photons or waves of electromagnetic radiation, and he thought about what it would look like and how it would behave, and that essentially formed basis for his special theory of relativity. Another example that I like is that Richard Feynman, in his lectures on physics, he talks that he wants the students to get the feel for physics. He doesn't want them to just recite the equations. He doesn't want them to recite the definitions. He wants them to intuitively feel what's going to happen if they are going to have a specific physics scenario. And in his books, he uses his words to very colorfully describe the processes and to create vivid images in people's heads. For example, when he talks about how the molecules of water jiggle around, and if they jiggle around fast enough, they overcome their electromagnetic, weak electromagnetic attractions, and essentially the water molecule separates and it transitions from liquid to gas. In the real world, we can essentially perform various experiments to get the feel for the phenomena. But often the students, we don't have the resources, so each student would be able to play with the experiment himself. You have the teacher demonstrate it. But you want someone to actually play with it, interact with it, change the variables, and see how it behaves. Another problem is that a lot of the experiments can be also very expensive to perform. They can be dangerous. They can harm the student or even the teacher, and so might be impossible to directly experience, like things for quantum physics, or on another end, the astrophysics. You cannot just take a planet, throw it into some orbit, and see how it behaves. If you take something more mundane, like for example, a piece of spring, you feel how the spring behaves intuitively. Like if you pull on a string, you're going to expect that it's going to pull back with a certain force. And you can then in physics learn the equations to calculate the exact force. You can graph its behavior over time and understand it analytically. Sorry, I have trouble pronouncing that. But the point is that essentially you are able to feel how the spring behaves. But we cannot do the same for astrophysics or some things in biology or quantum physics. But that's where the concept of breaking the laws of physics comes in again. You can essentially make a person interact with a simulation of some real-world phenomena that wouldn't be normally possible or safe because you're not constrained by the limitations of the real world. But that paradoxically allows you to understand it better. And that's what I try to do with the World of Comenius, essentially create some simulations, visualizations, and scenarios that the students could freely explore. Then in 2014, we essentially ran, in 2014, we used World of Comenius in actual class in secondary school in the Czech Republic, and we had students of various ages interact with it the whole day. We gathered a lot of interesting insights from this experience, but what became most apparent is that we needed for them to be together in the experience. The exploring, the experimenting, and the learning needed to be social. In the classroom, we saw how we actually saw how the existing students taught other students how to interact with the software. Like, for example, when a new student discovered a new feature or place in the software, you could actually see how it spread from whichever computer they were sitting at, as they went to the neighboring students and told them, check out this cool thing. And you could just see the excitement for the newfound things to spread. So essentially, we needed to make such interactions happen directly through the software. So we needed to make it networked. So the VR experience would be social, and it could even work across the internet. But there was also another problem. There were so many different experiences that we would have to build. There was another problem. There were so many different experiences that we have to build to be manageable and scalable with the current tools. But we would also have to make all of them fully networked, synchronized, and interactive, and it just wasn't possible to achieve with those tools that we had at hand. So we began working on a project called NEOS, which set out to design a new system for creating VR experiences. And NEOS has essentially two important parts or layers. At the bottom, there is a generic synchronization engine, and it's essentially a system which implements the network synchronization in a transparent way, building it into the world and object management itself. The benefit of that is that whatever you build on top is guaranteed to be networked and interoperable without you having to spend any time or mental resources on network coding. This saves on itself a great deal of time and allows you to create new social VR experiences much more rapidly. But what's more relevant to the topic of this talk is the layer on top. We also wanted to make the creation of the experiences much simpler for ourselves, but also enable non-developers like teachers and enthusiasts to create experiences from within VR easily. So they could build their own educational content and share with it others. And to make the building much simpler and intuitive, we had to change the way the common interactions are done. We based the tools on real-world ones, but we created an sort of idealized, more powerful versions of them. And again, that's because in VR, we are not constrained by the limitations of the real world. And that both gave people something familiar to latch on, because the tools were based on some real-world equivalents, but it also removed the tediousness of the real world that you don't have to worry about. So let me give you an example. Say we have two independent objects and we want to turn them into a single one. If we are using Unity Editor, for example, we find them in the object hierarchy and parent them under the same object. But that's a very counterintuitive way of expressing the interaction, and it doesn't transfer well into VR. Because sure, you can render the UI interface in VR and do the same, but it's just not VR way of doing it. So instead, think about what we thought about what we would do in the real world if we wanted to perform this interaction, if we wanted to turn two objects into a single one. And the thing you essentially do is grab a glue and glue them together. So that's precisely what we have in NEOS. I simply grab the two objects, you grab a glue gun tool, and you cover them both with glue. You let it dry, and you're done. You don't have to worry about the glue obscuring anything because it's invisible, so it doesn't look ugly. You don't have to worry about the glue strength or anything like that, or you don't have to wait for it to dry for several hours. Because the virtual glue isn't restricted by that. It's not important for its function, but other than that, it still works in the way you are familiar with. And essentially, all the tool that actually does in the background is it makes the hierarchy modification in the background. But from the user perspective, it's much simpler. They just glued two things together, which is a lot more intuitive way to do it. Here's another example. This is something we call a material gun. And it actually doesn't have full proper analog in the real world, because we don't have anything that would change material of an object. But it has some concepts that transfer from the real world as well. Essentially, we have these objects which we call material orbs, and that's the important thing. The asset for the material, it essentially becomes a thing. It becomes an object that you can grab, you can move it around, you can give it to other people, you can place it in some public space to publish it. You essentially treat it as it was a thing, like a printer cartridge. And then you can take the orb, you can insert it into the tool, and you can you can just point at the object and apply the material. So that's also a lot more intuitive way of doing it. But in the background, again, what it's doing is that it's changing the reference to the material asset in the data layer. But the user is, again, he's separated from that. Those are quite practical and relatively down-to-earth building tools, but we wanted to take the concept a lot further. And we developed a demo prototype called Neos the Origin. And there we demonstrated several world building tools that literally they give you superpowers. So it was taking the concept of breaking the laws of physics a lot further. So let's say you wanted to make an island. So you would essentially take sand into your hand and you would then hurl it into the environment, like throw it there. And the sun would shoot from your hand and you would just point wherever you wanted the island to appear. And the sand would pile up in the environment and form a little island. And if you wanted to add a little grass, you'd pick the grass and you spread it around and create grassy terrain. Or if you wanted to plant some palm trees or an island, you would take there essentially the seeds of the palm trees, and you would shoot them at the island, and you would watch them grow in front of you in real time. And that not only made the creation super simple, and it made it super simple to create beautiful environments, but it also made it very fun. So actually, you felt like you were building things with your mind, as if you had the control over the laws of physics of the virtual world yourself. So this was taking the concept further and essentially allowing the users to break the laws of physics from within the environment. There's also a lot of subtle behaviors, but important ones that are happening in the backgrounds in the system. First off, we defined complex interactions between different elements. For example, here you can see when you shoot the sand at the grassy terrain, you can see how the grass essentially starts drying out and it starts slowly dying. Or if you used snow, the grass would get all white. It would sort of like get a frost on it, and it would also start dying. And that's something that you would expect to happen in the real life. And a skilled designer essentially knows that. They know that how to build environments so they reflect how the real world looks like. So they reflect the processes from the real world. But beginner designers, they don't think about those things. And often when they are using the designer tools, they don't put those details in the environments they're built. And that's one of the reasons why they don't look so good. They don't look natural, because they just don't follow what we expect a real world to happen. And another example is that the trees and the plants, they grow procedurally, and they are using various noise functions to give them a lot of variation and different shapes and different colors. They essentially have a defined growth pattern, which is essentially based on the idealized way the real plants grow, like in biology when we learn about meristem and how the plant splits is modeled after that, but in an idealized mathematical way. And that essentially gives them nice natural look, because you can also have the rules react to surrounding environments. For example, if you have a light source or the sun, they can grow towards the light source. Or if you have like a virtual climate, you can have them react. Like if you plant them on some icy terrain, they will grow very, very weak and very small. And again, they will reflect how would a real world plant react. The problem, if we didn't have the procedural generation, and instead if we gave the students a few pre-made trees that they would instantiate in the environment, what the users often do is that they take the tree and they plant the same tree several times in the environment. Like they just copy it over like a clone stamp. And the problem with that is that it looks unnatural, because our brains, they are looking for patterns and they can spot the same tree very easily. And if you have like a skilled designer, the designer, he knows how to pick the trees and how to arrange them and rotate them and scale them a little bit in the environment so it mimics the natural look, so it looks good to the eye. But the beginner, he doesn't know how to do that. He doesn't have the skill yet. But so when you have it randomly generated in a way that mimics the real world, it essentially gives them natural look without them having to even think about it. One analogy I use for this process is that it's like a painter. Actually, one thing I forgot to mention is like this gives the beginners, it allows them to create nice, natural-looking environments. But let's say a professional designer wants to use the same system, and he could feel like he's limited by it. Like the system does things that he doesn't want to. But that is where another concept comes in, that the designer can actually put explicit constraints. For example, he can say how the tree is going to, how tall is the tree going to grow like. He can constrict the variations. He can precisely set forces that are applied to the tree. He can override the forces or the environmental influences to get the exact look he wants. But it's essentially like if like the system becomes a painter, and you can you can give as many details as you want to the painter. So, for example, if you are a beginner, you will tell the painter, draw me a snow landscape. And then every single detail is up to the painter. He can decide how is the landscape going to be shaped. He can decide if there are going to be trees. He can decide if it's going to be day or night. And all those decisions are for him. But if you have a more skilled designer, he can give the painter more constraints. He can tell him, put one hill over here and another hill over here, and put trees of this type, like over there, and I want a little lake over here. And then the painter is constricted, and the designer can get he can get closer to what he wants to do. But if he doesn't provide the detail, the system does it for him. So right now we are working on taking those concepts to the next level. And essentially, they are going to be integrated within ESVR itself. So all the superpower worlding will be social and collaborative, and you will be able to do it with your friends or colleagues. But the ultimate goal is to create sort of a dynamic between the users of different skill levels. And I have a lot of people often tell me that I have to decide who do I target the content creation software for. And it has to be either beginners or professional users. But I don't think that it has to be so black and white. And instead, I split the system into several layers of abstraction, and it allows anyone to go as deep as their skill level allows them. But what's important is that whatever they are built in a lower layer will benefit the layers, all the layers above, and the users of those layers. So let's take, for example, the procedural generation. The growth of the plants is described by a simple virtual genome, like a set of operators that describe the growth pattern. And the very basic user will just take the genome for the plant he wants, and he will put it in his environment. If he's a little more skilled, he can he can like put some constraints to get a specific look. But if he's even a more skilled user, he can actually start modifying those genomes and creating new ones from scratch to create entirely new plants. And he can then share these new genomes with other users who don't need to understand how they work. They just plant them in their own environment. And some users can go even deeper, and they can actually define new operators, like new algorithms for geometry generation, or warping algorithms for the geometry, which the genome builders then they can take advantage of, and in turn the content builders also benefit. And the same principle also applies to the tools that I talk about as well, like the glue gun or the material gun. A skilled developer can build entirely new tools from within the system. For example, tools for building and analyzing chemical molecules, if he's a chemist. A teacher or student or anyone else can then simply use those tools to create their educational content for chemistry. Or maybe it could be another user who's making some cool visuals for a sci-fi game. But they don't have to understand how the tool works. Only the skilled developer has to. And it's essentially similar to like the real life. In real life, you have people using devices for their own work that are designed by professional engineers. And the goal is essentially make this possible to happen from within the virtual worlds with the full collaboration and without the cumbersome restrictions of the real world. So the system is essentially letting the users break the laws of physics and take control over the virtual world themselves. But what's important is that the level of control depends on their skill level. And this gives them, I think this gives them a natural challenge. If they want to have a greater control over the world, they need to learn more and delve deeper into the system, which in my opinion, it's a lot more natural approach and sensible approach than giving them some like arbitrary forced challenges and limitations just to give them a sense of progression. So what does this all boil down to? So essentially, when designing tools for virtual reality, we imagine what we would do in the real world if we had superpowers to make anything happen with just a mere thoughts, and we work from that. It works for all kinds of experiences, whether we are making a game, atmospheric experience, educational content, or even content building tools that and allows you. That essentially allows you to. This principle allows you to come up with all kinds of cool and compelling ideas that you wouldn't otherwise be able to, or it would be a lot more difficult to come up with these things. But I think the important thing to keep in mind is that also the constraints of the virtual world are very different from the real world, and essentially whatever we imagine can in a way become real. And we often ask ourselves, is VR really necessary for this? Would this work well without a headset on a computer screen? Are we just throwing VR at our project? And I made a mistake in my past during the DK1 days, where I tried to make the principles work both on screen and in VR, but that it either leads to a lot of compromises. So I didn't fully utilize the power of VR, or some crazy workarounds and control schemes to make the stuff work on screen as well, but that didn't make it particularly pleasant. I think at the same time, it's important to have some elements of familiarity, so people can have something to relate to and have a proper context in which to understand the virtual worlds and the objects they will interact with. If you are to give them something completely alien, they wouldn't be likely able to comprehend it or understand what's going on. But if they start from a familiar starting point, then they have something solid they can explore the unusual world from. But I think at the end of the day, the idea is that we only get to experience one real universe. But VR allows us to build many more, so there's no reason they have to behave exactly the same. We might never get to travel to other stars and galaxies, but with VR we can travel to other universes in our heads, and that's what makes it so powerful and what makes it so fun. So I think this is mostly all from me for this topic. So I will now leave time for questions. So I'm going to check out the chat and see if there are any questions. No, okay, thank you. I have some comments here. Immerse is asking how may you work on this. I'm not sure if this should be how many of you work on this. So essentially, like for the most part, this is just me. We have sort of have a small team for now, but essentially the programming, the design, and such, this is mostly me. And I have my co-founder Karel Hulec. He's often like bounce ideas of him and discuss these things with him, so he's helping in that regard. But we also have a graphic designer, who is like designing the graphics for the tools. But for the most time, we keep the team small for now, because like the design of the system is to be highly modular, and I try to keep it. Like the core of the application. I try to keep it to be very elegant. So I try to design it in a way that it's both elegant but also highly modular. And we plan to essentially start expanding our team in a few months or so. Essentially, we I want other people who would start working with me to be able to have like their own projects within this project. Like they would say, I want to design this new subsystem, and they could just write a bunch of components and systems and essentially have it interact with the system without them having to touch the core. And so there's another question: why do your graphics stand out so much compared to other experiences? Well, I don't really know. Like, I often try to like because we are such a small team. I often and oftentimes it's just me working on the projects more or less. I often try to like do something that is very efficient. So I have to partition my time in a very efficient way, because there's, let's say, there's a month to build something. Like we are building a game for a VR jam. So I essentially decide what's there going to be in the application. I write the software, and I often use assets from like 3D assets from the Unity asset store, which is a great source. But I also spend a lot of time like picking the assets and adjusting them a little bit, so it all seems that it fits together. Like it's all part of the same world. Because if you just grab different assets and they don't mix well, it gets this cheap look. There's another question, and can you convert into common standard formats? Essentially, right now, I'm not sure if the question is specifically for the procedural generation or the NEOS itself, but right now, this is not implemented yet because that wasn't a priority, but it will be possible in the future. Essentially, the geometry data, it's generated in a fairly standard way, and there are nice libraries. I'm actually using a library called Asimp. You can look it up, and it supports importing a lot of different graphic formats, and it also supports exporting them. So using that will make the export process relatively simple, especially like if it's just geometry data. But if the export, if you wanted to export like the entire world itself from within NEOS, then there is a problem that you would lose all the interactions. So, and because for the interactions, you need the NEOS system, you need the synchronization engine, you need the system to manage the worlds, you need all the code for the components that provide the interactions, and without that, you would essentially have to somehow replicate it in the target engine. Like if you wanted to export and run it separately in Unity, and essentially you would have to take NEOS and put it in Unity. And at that point, that's essentially what NEOS is. So, like, it doesn't make much sense to just copy it like that. But you could, of course, like write different exporters. Like, if you want to support a subset of functionality and you want to export and somehow translate like some of the interactions, say, into Blender or Unreal Engine, then you could do that eventually. Like, but from the principle, if you wanted to export like the entire world itself, it doesn't make that much sense. But for the assets, the 3D models, and even later audio and things like that, it's going to be definitely, the export is definitely going to be supported, because one of the goals I haven't mentioned in the presentation for NEOS is that you can essentially you can use the collaborative feature or the network synchronization engine to build a virtual studio. So, for example, you build a virtual studio for where you can collaborate with colleagues on creating or modifying geometry or textures, or you can build a virtual studio for composing or synthesizing music, and you would be able to work from within VR with others and then export the results of your work. So there's another question: can I access VR PSVR with your engine? So right now it supports it uses SteamVR, and I have integrated the Oculus Rift support with the touches, because I use hands in the internal build, but it's not released yet. I don't have specific plans to support PSVR. I'm not sure how it fits with their platform, but essentially the Oculus Rift and Vive, they are essentially both supported, and also I have Android support, but I'm still like debugging some things. but Android support is going to be in the system as well. And PSVR probably in the future. Like the problem with PSVR is that they have like I cannot just release an like an executable file for people to download. So because of that, it's a little more complicated. Yeah, I'm going to support Leapmotion as well. The support is not there yet. Leapmotion was supported in the concept demo Neos the Origin, but for the full Neos, it's not integrated yet. But that's something I want to add in the future as well. Yeah. One thing with the Leapmotion is that sort of currently the tools that there are in the system, they are designed to work with the controllers. Because when you are holding a tool like a physical tool like the Vive controller or the Oculus Touch controller, it translates into a real world tool. Virtual tool. So that's sort of like a direct sort of one-to-one translation. But if you have your hands, it doesn't make sense to hold the tool. So I'm thinking if I should give some like emulation like system, so you could like equip a tool and use your fingers to use that tool. But it's not a very good way of doing it. So yeah, integrating Leapmotion requires sort of rethinking how the tools should work as well. And you could see that in I can return it. You can see that in the Leapmotion version of the Neos the Origin, and the way it was integrated is you essentially like you touch something and then you like thrust your hand forward and that will activate the action and start hurling the sand, or you thrust your hand and it will like shoot the seed of the plant and it will grow in the environment. Or if you want to grab something, you make a grabbing motion with your hand. So that was designed specifically for Leapmotion, and it works relatively well. But if there's another, the second version, this one was working with the Razer Hydras, so that also mapped quite well. But you can see that it has the interactions were a little bit different. Like you had these little menus to open, and it didn't map. The functionality didn't map the same way. So if when I start integrated the Leapmotion, I need to sort of think how to best map different interactions and different tools to the hand. So are there any other questions? So thank you. Yeah, thank you very much for watching. So I guess if there are no other questions, I think I can. Oh yeah, more questions. So how are you getting the word out? So well, right now I'm actually started publishing like devlog videos, and especially for Neos. It's essentially on my YouTube channel, and I usually release it on Reddit and Twitter and things like that. I always record like a short intro with where I talk about what's new in the system and sort of do a quick showcase. And after it, I follow it with a full footage of us, me and Karel, essentially just playing with the system and showing off all the stuff it can do and doing silly stuff. But this is mostly tailored for the alpha releases and alpha versions, because I don't try to like be very like generate a lot of hype at this moment, because the system is still in relatively early stages. It's still very like call it like developerish. It has a lot of counterintuitive behaviors, because a lot of the things in there are essentially just for us to test out the different behaviors, different tools, and test if the underlying engine works correctly. So I don't want a lot of like masses of people trying it out yet and finding that it doesn't behave the way they want, or having trouble interacting with it. So I try to keep a little bit lower profile for now. Later on, I will start producing like more flashy videos where I sort of do quick showcases of some things that have great cool effect. So I think I'm over. It just passed the 40-minute remark. So thank you very much for the questions and for watching. And goodbye. I hope you enjoyed the presentation, and goodbye.